Welcome, welcome. This is my 5th grade general science class. My name is Miss Joseph, and I'll be teaching your students the world of science. I'm excited to see you all, and I hope your students and your kids come and learn, and I am very excited to meet you all. So now we're just going to talk about the course overview. For the course overview, we're going to talk about the key topics that we're going to be learning throughout the course. We have the Earth system. We have the properties of matter. We also have chemical and physical change. We're also going to be talking about the force of motion. We're also going to be talking about the water cycle, which is my favorite one. We're also going to be talking about the types of rocks. Now we have other topics that we're going to be talking about throughout the course, but these are the main key topics that we're going to be starting off with. My philosophy. I believe that everyone has their own way of teaching, and I believe science should be fun for exploring ideas to learning new concepts. Science is everywhere that we know. It helps us solve problems, make new inventions, improve our daily life. It also helps us to think critical and make decisions based on evidence. Now, I have a question, a quick one. Do you know what evidence is? If not, it's okay, because we're going to be learning that throughout our course. Science should and always be fun. Science is fun. It's not just reading something, but you're going to also be doing science experiments. You're also going to be learning about it. You're going to be doing investigations. You're going to learn how to keep data. All these things you're going to be learning. And also, for me, my expectation is for you to ask questions, have concerns, and together we're going to learn how to come with those concerns and figure them out, which is problem solving, and that'll be really great for us. You will use your curiosity and creativity to join us to explore the world together. So I have a few teaching strategies that I have. Asking questions and defining problems are very, very important. Having the students engage, ask questions are a great way to know where the students stand or what are they learning or what they are missing. If the student is not asking questions, maybe sometimes it's a little concern for the teacher, but it's also a great way for the kids to participate in asking questions, and even the students can answer their peers' questions if they know. We're also going to be developing and using models, and I believe models are our best way in science. It helps visualize their ideas, and it also helps the students to study and know their ideas by creating models. For example, the water cycle. My favorite one, the water cycle. We'll have the students model the water cycle based on the structure and how the models are made. And the students will design it and be creative doing it themselves. And planning and carrying out investigation. The students should be engaging. And a lot of hands-on experiments, hands-on activities, also a lot of designing. The child should be excited when it comes to science because you're building, you're destructing, and you're doing different things. That's helping the child develop these skills in science class. We're going to learn how to analyze and interpret data, which is going to teach the kids to analyze data and draw to a conclusion, their own conclusion. And then we're also going to be talking about the engagement and the argumentative from evidence. And these should help the students be able to identify their problem and try to resolve it. And also will help the students argue the conclusion based on the evidence. The students can debate. Students can also have class discussions, class debates for these science argumentatives. For the obtaining, evaluating, and the communicating information, the teachers Us as teachers deliver the information to the students, and the students should be able to do its research and communicate, not just with themselves, but with class peers and even adults. If they have something they don't understand, it's okay to ask questions and have some of their own knowledge. If they feel like the experiment we did wasn't accurate, it's okay to have your own knowledge about it. Let's move on to the next slide. Now, about the argumentative lessons. This is an overview based on what we're going to be doing. The argumentative in science, it helps students develop critical thinking. It helps them develop reasoning, communication skills based on engagement. Students can learn and justify their ideas and also share them with evidence, and there's also different viewpoints. Everyone always have their own viewpoint. So it's okay to have your own ideas, and it's most important to share them. Don't keep them to yourself. Because maybe your idea probably helped the other students, and then you guys brought your ideas together and made a big argumentative. And also, in our argumentative, we have some examples. And like I said from the last slide, debates. Debates are very important because you want every individual, each and every student in the classroom to participate, to engage, communicate their ideas, to share their ideas. And doing that, so we're providing a safe environment for them to learn. So the purpose of an argumentative is to teach students to support their arguments with data, engagement, and a respectful disagreement. Classroom discussions are one of the greatest things that we can do as teachers to help students build their ideas without differences. There's always going to be differences, but we do it in a safe and a clean manner. Also, we can also combine ideas, encourage students to use their critical thinking and give feedback to other peers in their class. Also, we're going to do a lot of evidence-based writing. The students will write essays arguing the states that, like, for example, the state of matter, which is solid, liquid, and gas, is most important. Using these evidence from the class helps the students find reasoning, helps them also communicate. We can also do role play. As the students are doing these experiments, they can break into groups, and each group has roles. Each person in the group has a role, and these kids will be responsible of their role. Moving on to the next slide. Now, we're going to talk about our science knobs. These are our rules for our science class, which is every student has to listen carefully, pay attention when others are speaking. This is very, very important. Giving everyone a chance to share their ideas. Use evidence to support what your claim is, what your idea is. Always back up your thoughts with facts, data, and examples from the experiment or the reading. Maybe you're reading something and you can use that to back up what you're saying. Ask for evidence when needed. Like we can do different things. You have sentence starters, like what makes you think this happened or this did not happen. As teachers, we should start off the conversation. Have open-ending discussions where the students can brainstorm their ideas. Be respectful to each other. Clarify questions. Be clear. If you're not clear, the class will not be able to understand what you're saying. And stay on topic. You have to stay on topic. If you fall off topic, everyone's going to be totally confused, right? So it's okay. Sometimes it happens. But because we are many scientists, we should learn how to stay on topic. And it's okay to agree to disagree, but we always have to be respectful. Here, I also have some sentence starters that you guys can use. Like, I agree with because, or I disagree because, and there's many more. Moving on to the next slide. Thank you. Thank you for watching. Thank you for coming to our science class today. Bye.